measuring methane. And people at Penn State worked on that for about 10 years, and that fell apart. Recently, we have a paper, it's in press, pointed out that you don't need any of that. If you increase cloud coverage of thin clouds in the tropics, 80–90% cloud cover would be enough to get rid of the paradox. But for it to do so, the clouds would have to constitute a negative feedback. That's one which we have described before. Another line of inquiry has to do with the time response to the system. One of the counterintuitive things about sensitive climates is the time it takes to reach the larger temperature gets much longer. The idea is just thermodynamics. If you have a highly sensitive climate, it means a very small flux is associated with big temperature change, but you still need flux to change the temperature of the ocean, so it takes longer to reach it. You can use this to look at situations when you have sequences of volcanoes, and you had that in the late 19th century. And if you have a sensitive climate, I won't go through the details of this, then the perturbations due to the volcanoes will persist for many years and give you a kind of secular depression of temperature. If you have insensitive climates, then all you'll get are bleeps due to the volcanoes, which is pretty much what the data had. There's a third line of inquiry known as the hotspot. All the models of greenhouse warming show maximum warming occurs 5 to 10 kilometers above the surface in the tropics. The balloon-borne thermometers don't show any such effect. And so one could conclude that very little of the warming over the last 20, 30 years, 50 years, is due to the greenhouse effect. The response to this was curious, and when I'm saying the field is a little bit peculiar these days, one of the first attempts was to say, throw away your thermometers and try and infer the temperature from the wind. There's a guy called Sherwood. That didn't fly, and so there was then a paper that appeared a year or so ago with 23 authors, including the current head of IPCC working group 1 and Center, in which they stretched every possible source of error in the thermometric data to conclude it was possible that the data was consistent with the models. But as somebody pointed out in a recent paper, extremely improbable. There was a fourth line of argument, which is by Steve Schwartz. He has a couple of papers looking at climate sensitivity by studying the rate of change of ocean temperature. And these inevitably lead to the conclusion that the temperature sensitivity to a doubling of CO2 is order 1 degree or less. The most recent is stuff that I've been doing with a postdoc, Yong-Sam Choi, in Korea, which is to simply look at tropical incidents of warming and cooling. The red are incidents of warming, blue cooling. And, by focusing on those larger than the noise level, the ones shown here, one can use satellite data that has been available since 1985 in order to see how the outgoing radiation changes with the temperature. And the idea here is pretty simple, and I won't dwell on it much. This is the data. You can do two things. You can measure this. You can also take the IPCC models and see what they say you should have seen. And let me skip the equations for a moment. You can have them. I'm willing to send the PDF of this to anyone. When you look at the models, what you see is this negative slope. And this indicates a positive feedback and has led virtually all scientific bodies to declare that this property is robust. Now, I should point out what this means. The negative slope implies that outgoing radiation decreases relative to what's called the zero feedback flux. It's simply a statement that in terms of the greenhouse, the feedbacks are reducing the outgoing radiation and making the blanket thicker. That's the positive feedback. And that's completely consistent with the model behavior. You can relate this directly to the sensitivities that the models display. But when you look at the data, you get exactly the opposite. You get an upward slope, which means, again, relative to the zero feedback phase, you've made the blanket thinner when you increase the temperature. You've inhibited the warming due to greenhouse effect. And so you expect less than 1.2 degrees. Now, you can go through the mathematics, and there are explanations of various things here, but the upshot of it is, within the uncertainties, this is telling you that the sensitivity is going to be between 2/3 of a degree and 0.87. The average value we get using zero feedback estimates is about 0.77 degrees centigrade. The sensitivity is well constrained in contrast to model sensitivity and is much smaller than model sensitivity. Remember, even with model sensitivities, only the largest values are associated with alarm, and even this alarm is doubtful. So where does this leave us? We see that the very foundation of global warming alarm, which is really the existence of positive feedbacks, is almost certainly wrong. And the question is, where does one go from there? And the answer is, it's very hard to tell, given that to simply note this constitutes an insult to the sensibilities of the educated class and the entire East and West Coast. Thank you.